Anybody here use ROS at the moment? Great. Because I'm not here as an expert in ROS at all. I'm here as someone who's starting to use it. I work at Middlesex University, technical tutor, do a lot of Arduino stuff. Used to work at Tinker and ran a lot of Arduino training courses. And we were looking at doing robotic stuff with the students. I don't have a glossy presentation, I tend not to do glossy presentations. And there is a live demo of sorts, but I found out the one thing that I didn't test was plugging in a MacBook running Ubuntu to a Thunderbolt VGA adapter, and that doesn't work. So I can either boot into Ubuntu and control the robot, but you can't see anything on the screen there, or I can show you stuff but not control the robot. So we'll look at some stuff, we'll talk about ROS, and then I'll fiddle about with the robot a bit, and we'll play around with that a little bit. So at Middlesex we were looking for a robotic platform to do stuff with students, and the classic issue with a lot of robot stuff is that you get to control the motors that drive around, and the robot that we're going to play with there, classic sort of circular robotic base that will drive around. And you work out how to drive the motors, you work out how to turn them on and off, you work out how to steer them, you can do a bit of driving about, and you can do the kind of stuff that they were doing with Logo years ago. And then it gets really, really, really complicated. Really, really hard. And a lot of robotics research projects end up spending all the time that they're supposed to be developing stuff actually rewriting loads of code to do all the things like planning the path that they're going to take through things, detecting stuff and working out what it is, because there was no kind of agreed standard about how you would do that. So code that people had used on one project, you couldn't necessarily use on another, because there wasn't even agreement about when you're talking about X, Y, Z, do you talk about it being that, or do you talk about it being that? And if all your code is written using that, and someone else used this, then you're getting a lot of complication getting it to work. And when you're talking about rotation, are you talking about that, or are you talking about that? So there was a lot of incompatible stuff out there, a lot of stuff that people wanted to use. And then there's a company called Willow Garage. They're American, so you say garage, not garage. And they make robots, and they're the maintainers of OpenCV. Have people heard of OpenCV? So OpenCV, a very well respected open source computer vision library. So if you're going to do computer vision, you don't write it from scratch, you use OpenCV. So Willow Garage have been maintaining that for quite a few years because they make robots. And so having a really good vision platform for robots is clearly quite important. And they feel that maintaining OpenCV and sharing it with the community and having other people using it means that they end up with a more powerful product. Because what they do is they sell robots, they don't sell software. So OpenCV is available. So guess how much one of these costs?
40, 50,000.
Okay, the big clue is that as you go down here, before you get obtain quote, you get ways to search for funding. That's always a bad sign, and then it says obtain quote. So if we go to obtain quote, so obtain quote, $280,000 with the 30% open source discount, but not including taxes and shipping. So it's going to be a bit more. So charging for the software is kind of neither here nor there. PR2 is a very, very serious research robot, but they actually got involved in donating loads of them to people who wanted to use them. So they sold a load for $10,000 as long as people contributed source code to the community so that other people could use it. And what Willow Garage started to work on was a thing called Robot Operating System. So Robot Operating System, which we will have a link to on their main page here, Robot Operating System is middleware. It runs on a computer that's already running an operating system, and it handles a lot of the specific things that robots need to do. And a lot of the slides that have been coming up today, I mean, ROS is a classic example of a domain-specific implementation of things like nodes and communication protocols. So the specific domain is about robots and getting them to move around. For a few years they've been maintaining it, but they've just floated it out, and there's an open source robotics foundation, which is now the home to ROS. They've been releasing very aggressively. They've been mirroring the Ubuntu releases, so about every 6 months there's been a major point release. It's been going about 5 years. It's being used very heavily in universities, so almost every university that has any kind of significant robotics action, they're using ROS. So a huge amount of contributed code. And it's fairly simple, really, he says. And then he will totally fail to get it to work in any way, shape or form. Let me just check my notes and see if I said all the things I thought I would say at this point. This is the closest I get to a PowerPoint presentation. So the key thing that they wanted to do was use stuff that's available rather than reinvent stuff. So it's about plumbing things together rather than writing new code. It's about taking things that exist and plumbing them in. If something starts to get big, then spin it out and make it a separate thing rather than keep it as part of ROS. So they're very keen to use other stuff and get other people maintaining their things individually. At its core, it's about plumbing. It's about message passing. It's about talking to the base and telling the base to move somewhere, the base giving you information back about where it is, talking to something like a Connect and getting messages from that, and joining them together. So what you need to know is what's the difference between where the wheels are and where the camera is that's recording stuff. Or if you've got a multi-joint arm, when this is here, what do I need to do to control this point? What do I need to control this point? So you end up doing lots of things called transforms, where you're calculating what's the orientation of this, how is it related to that, how is it related to that, and you have something that's defined as the base. So they've developed a thing called a unified robot description format, which is an XML format for representing a robot model. So you build a UDRF model of your robot, and that's kind of things like how far apart are the wheels, how high up is the Connect, if it's an arm that moves around like this, how long is that bit, how long is that bit, what kind of movement have you got there, how many fingers has it got. And once you've got that URDF model, you can then interface it to pretty much all the stuff that ROS does. So your really fiddly bit is getting your URDF model done. We cheated and bought one of their cheaper robots, so you get your URDF model already. But because it's all open source, there's lots of them out there. And the documentation about how to do it is out there. It's currently implemented for Ubuntu, hence my issues with getting it to work on my laptop. They're not against implementing it on other platforms, they just haven't got the resources to do that. And most of the build process is very strongly aligned with the way that Unix works. And so implementing it for Windows at the moment is quite a difficult process. But they're aware of that, and it's still very, very young. It's only 5 years old, hasn't been going that long, so they're looking very actively about how they could implement it for other things. It's been implemented for Raspberry Pi, you can get it for BeagleBone Black, you can get it for all kinds of other things in varying states of experimental release. It's mainly available for Ubuntu and on 12.04 because that's the long-term stable release. And basically a ROS application is a group of processes running and communicating with each other. So you have a process called ROS core, and you launch that, and that's a server. And anything else that gets launched is called a node. And basically they're all separate programs, usually in C++ or Python, but you could write it in anything you want as long as it sends the messages in the right format. But all the code that they produce and show is C++ and Python. And nodes can publish or subscribe to topics. That's how you can pass messages backwards and forwards. Or they can provide services, which is basically that you can ask for something and it will send you something back. So topics are about broadcasting and receiving, services are asking and getting something back. And then there's a thing called a parameter server that basically holds global variables, so you can ask it what's the current value for this, what's the current value for that. And the nodes can be launched independently and taken down so you can build stuff up slowly. So there would be nodes, for example, that would know how to talk to a Connect. So for this robot, you would launch those nodes. If you had another robot that had a Connect, you would use those nodes with it without having to rewrite them. And the URDF would take care of all the transformations that needed to happen because the Connect was sitting in a different place on a different robot and was physically configured differently. It's network based, so once you've got a ROS core running, on that network, any computer that can see ROS core can run nodes. So you can develop stuff on one computer, and if it starts to get too difficult, you can float stuff off to other computers very easily, because a lot of the path planning stuff is hugely computer intensive. So you don't want that running on the robot, because your batteries will die very, very quickly. You want to be sending information back, calculating a path, sending the path back to the robot, so the robot then goes round it. So you can be developing stuff on one computer, you just need to move the nodes onto another computer and launch them on there, and they'll find the core and hook up and take care of everything else themselves. So the nodes form a graph, and they can arrive and leave at any time. And a complex robot soon becomes a huge myriad of processes running, and it's quite difficult to manage. But it does loads of really, really good stuff. So some of the really difficult things to solve for a robot are... Can I get this to go full screen? If I go to here. A thing called reverse kinematics. Have people heard of reverse kinematics?
Reverse kinematics.
The movement team at Willow Garage is proud.
Shows you how much I know about it. I don't even know the proper name. So for an arm that moves around like this, what you're interested in is where the hand's going to go. So you want to specify where the hand is, and then you need to work out how all those joints need to move to get the hand to that position. And there may be multiple combinations of positions that would work to make that happen. So starting from those coordinates, going back, working that out is quite complicated. So they have, you can get visualizers. So once you've got the URDF, you can play around with something in a visualizer, and it can calculate the paths that it will take, and it will do collision avoidance on all the joints. So you can put in a visualization of the space that it's going to work in and say that you mustn't hit these bits, and then as you drag it around, it will calculate those paths.
As environments for the robot to operate in. Movement can also integrate directly with the 3D sensors on your robot to build an environment representation. The kinematics and motion planning components in Movement use the environment representation for collision avoidance, generating collision-free paths for the robot to follow. Fast dynamic updates allow Movement to react quickly to changes in the environment. In this example,
$280,000
different waypoints while sharing the workspace with the person. The robot can stop.
This is where someone comes in and obstructs it, so it works out another route to get to where it needs to go without hitting the person. And that's happening in real time. So it's detecting that the person's there and in the way and working out a different route to take to get to where it needs to go.
Between the robot and the person. Movement can deal with high degree of freedom robots, allowing you to motion plan for complex tasks. For example,
and you don't have to implement the algorithms to do that. You just have to give it the parameters and tell it how close to the path you want it to stay, how you want it to vary.
Evaluating Cartesian and effector trajectories. This allows a robot designer to quickly determine how well the robot will do in different tasks before building expensive hardware. Movement will soon include integrated components for advanced manipulation tasks like generalized pick and place in unknown environments by integrating with object recognition and grasping. Such high-level capabilities will provide users powerful tools to build advanced applications, integrating perception, navigation, manipulation, and control. To download and start using Movement, visit movement.ros.
And it's very actively maintained, very, very vibrant community. So I'll do a little bit. So this is running in VMware on the Mac at the moment, but I can't hook that up to the network to talk to the robot. It's worked in the past, but of course it didn't work today. Nothing ever works when you want it to. Okay, so if I want, you've installed ROS on this machine and you launch stuff from the command line. So if we want ROS running, we get ROS core running. So we've now got the ROS server running. So I'll open a new terminal window and ask it to tell me what topics it is. So the server's running. There are only two things running at the moment. Nothing much is going on. Basic server. Here I have some things that I prepared earlier, so I don't have to forget what I'm going to type in. So I'm going to run a quick simulation. Okay, so I haven't got a robot at the moment, but I can play around with a visualization of one. And now I want a way to control it. So I'm going to start a separate node. So each of these terminal windows is starting a new node. And now I can use, if I can find the window, there you go, I can now use the arrow keys to drive the TurtleBot. So we're now in sort of 1970s Seymour Papert territory. And I was saying it gets very confusing very quickly, so there are ways to visualize what's going on. So I can ask it to draw a graph of what's currently running. I get loads of errors, but it still works. So at the moment, there's a turtle sim thing running. There's a teleop turtle running, which is, I can use the keys to control it. And there's a topic that's going between them. Turtle 1 command velocity. Teleop turtle sends it, turtle sim listens to it. I could stop teleop, I could start another process that was talking to it as well. And for a robot with lots of controls going on, this would be just a huge mesh of stuff. And there's loads of really great debug tools like this. There's a really nice visualizer, all kinds of stuff. So shall I get the robot to move around a little bit? Yeah. So you won't have anything to look at up there. So I have to shut it down, reboot it. But what we'll do is we'll do so this is the robot. So it's got a netbook on it, running Ubuntu, which has got ROS installed on it. I've got ROS installed on this machine, running Ubuntu. It's got a Connect, and it's got a base that's very much based on the Roomba. So a lot of robotics people were using the Roomba, the vacuum cleaner that drives around your living room, which had a serial port on it. And they very handily left the serial port on it when they sold them in shops, and released the documentation for the serial port so that people could actually use it to do things. Because at the end of the day, they just wanted to sell the hardware. Yeah, it's not going to come up now, is it? Now, what you won't be able to see is the really exciting bit, because what we can get it to do, I can do the same kind of teleop thing where I can drive it around using the keyboards, but I can turn the Connect on, and it can use the camera in the Connect to start drawing and mapping the room. So as it's driving around, it knows where it is, and it can tell where things are, and it draws the walls and places where it's moving around. You can then save that as a map, and you can start saying, you're here at the moment, I want you to go there, and it knows the bits it can't go through because it's seeing things that are in the way, and it can work out the path that it needs to take. We won't get to that point because that bit didn't work when I tried I told you it's a work in progress. Right, we haven't quite booted into a Ubuntu, shall we? No, I couldn't put it on top of the projector, that would fall off. That would. Right, I'm at the login screen and I'm logging in.
What do you see on the screen? You try turning it off and on again.
Believe you me, I've done that quite a few times over lunchtime. No, it still doesn't see that it's got a monitor connected to it. Right, so I'm just going to run ifconfig and check that I've got the network address that I think I'm going to get. Yeah, let's just turn off the Wi-Fi so that I don't get confused. Okay, not the most compelling demonstration, is it? Yes, I've got the address I expect. Right, okay. So the first thing I'm going to do, SSH into the TurtleBot. TurtleBot at 192.168.0.101. Okay, while I was thinking about that, I'll remember to turn the bass on, otherwise it's not going to move. Okay. So this is working so far, you'll be pleased to know. I'm not swearing and shouting, so we're moving forward. Okay, so I need to launch the processes on the TurtleBot that will be able to control it. So let me just get my cheat sheet. Which one is it? There you go. It's just launching. Start recovery. No. It's one of those days. I don't need to recover it. Okay, so fingers. No, it's definitely one of those days. If you all shut your eyes so you're not looking at me. And then it will work. Yeah. Cancel that. Yes. Cancel. Okay, and then just open the document again. Thank you. Right. Okay. I'm now going to launch the process on there. Fingers crossed. Okay, that's the sign to say that it's working. So I shall open another window and again. Just need to wait for the window to come up. Okay, and launch the keyboard control. Of course, this would be so much more entertaining if you could see me copying and pasting stuff at the command line. But, okay, so now I should be able to press the keys and drive the robot. Okay. Now we want to see what's coming from the Connect. Now we'll have to, at some point, gather around.
Hold it up and turn it around, and those with good eyesight will be able to see it. The screen. Your laptop.
You won't be able to type then.
Yeah, but
Give the language with Weldin and pointing at the screen.
or just an operating system that works with projectors. Right, I'm getting loads of errors, of course, because nothing else is working there. So why should this work? let's just see if it works anyway. And if not, it goes to the pub. Oh, no, wrong process. So, this is kind of towards the end of the presentation, as you probably guess. Has anybody got any questions?
Did you say that that base was based on Roomba or actually was a vacuum cleaner?
No, it's based on Roomba. They'd used Roomba to do that kind of thing. And to some extent, they then kind of learned, well, these are the things that are good about it. These are the things that we'll do instead. So it's got some nice features, like lots of connections for more power and things like that. So there's a 12-volt supply on the back. You can put a big chunky rechargeable battery in. Yeah, no, this isn't quite working. I'll do it again later and people can see it.
My other question is, do you need it? Do you need for like a whole laptop on there, or do you be using something with power and stuff?
It depends what you're trying to do. So, like all those things, how much processing power do I need to put there? Depends how much you want to do. If you want to talk to the Connect, yes you do, because I don't know that anyone's got the Connect working with the Raspberry Pi yet.
The USB doesn't work well.
Yeah,
USB,
the last time I saw it, they hadn't done. But you can run ROS on a Raspberry Pi. So if you were just driving the robot base, you could do that.
I think
But if you want to do the camera vision stuff,
a BeagleBone would probably work.
yeah. I mean, BeagleBone is a better platform for it.
Yeah.
There's somebody worked on Google Summer of Code getting it working on BeagleBone.
Yeah. We weren't using a Kinect, but we're using a similar webcam. We've done something kind of similar.
So that's how quick, easy and convenient it is. How well it all works. But I mean, I'm just here basically because, you know, share early, share often. I haven't got it all working, but it's got everything that you would possibly need, and lots of people working on it. Really good documentation. Documentation on their website is some of the best documentation I've seen for an open source project. Talking you through how to get stuff up and running. Responsive forum, all those kind of things. I haven't been as excited about something that I've found that I wanted to use since I found Arduino. So it's kind of, it's not going to be as mainstream as that because not as many people work with robots, but I think it's potentially a significant thing. I'll fiddle away somewhere and get it running, and it will be drawing in the visualizer what it saw, the bits that were obstructions, the bits that weren't, and building up a path. And that would have been the down moment. But the down moment never arrived.
Robots.
So that's it, unless there's any more questions.
What was that, if you ignore the laptop, what's the rest of that kit run to?
This was about a grand, including the Connect, including the laptop, including the base. They publish the files for making these, so you can make your own. You can buy the base by itself. You can buy your own Connect. Documentation around it. The base, they don't publish the documentation for you. Buy that. But basically, any kind of moving base that you can build up a UDRF for, you can start using.
What's the sort of base price for the lowest model robot arm?
I don't know. You could make one with pan and tilt server.
You can buy them from Macklin for about 30 quid.
Yeah, but it's not going to run ROS, is it?
No,
if you're running your RDF for it, yes
yeah,
it would.
back onto it.
It probably hasn't got one out of the box.
Yeah.
So, you know, we paid a bit more for these, so they came with that already. So we could get our heads round actually getting it to do stuff, and then go back and look at how you do stuff like describing the platform and stuff. But there's about 30 robots that have got well-developed stuff for ROS. Most of them are in that video. Driving around climbing up stuff.
How abstracted is the ROS thing from actual hardware? Is it possible to just go ahead and do your own homebrew arm, for example, and get the this ROS stuff to work, you know, with that hardware? Or
Absolutely. You would just need to write a node.
Yeah.
A node that got the information in that you needed, or published the information that you wanted. So it's very common. So there are things like laser scanners that are, do the same kind of thing as a Connect, but they cost a lot more. They either go 360 or they do about 270 degrees, and the laser's scanning around quite quickly and giving very accurate distance. So it's not building up a big picture, it's doing a line, but it's much more accurate than the Connect. All the common ones for those that you can buy, people have written notes for. So if you buy a Hiroko laser scanner, there's a Hiroko laser scanner node. You launch it with the scanner plugged in and it just publishes the information. You could do exactly the same.
Just building on that question, is anybody using ROS for unmanned ground vehicles or unmanned aerial vehicles?
Yeah.
A bit bigger?
Yes, yes, yes and yes. Yeah. In that original video that was showing as people came in, all those robots are running ROS. So they're trialling stuff in healthcare. There's a company called Clearpath Robotics in America who do a lot of all-terrain vehicles, and they're very strong supporters of ROS. They have a boat that runs ROS, about that big, that is doing sonar scanning on lakes. So going up and down, measuring stuff below and doing plots of lakes and tracking pollution moving across lakes. They've got a thing called a Husky. It's about that big with big chunky wheels that drives around and is autonomously. There's lots of quadcopters that people have done implementations for. Yeah, tons of stuff. We're going to be running.
What does ROS actually stand for?
Robot Operating System.
I should say that.
Should have started off. And we're going to be running an event at Middlesex at some point, but we haven't been able to get definite dates. They keep changing because we've got 10 of these that people can potentially play around with. So we're going to do a weekend. It would be called a hack day if the IET were happy with the word hack, but they're not. So it's not called hack in any description. So it's probably going to be called a workshop, but we won't be actually teaching people stuff. So you'll kind of come along and play around, but if anybody's interested, let me know, and we'll send you details when we know what it is. But it'll be before Christmas sometime. Also in London, there's going to be a group of people meeting up who are interested in doing this kind of stuff. So again, if anyone else is from London or wants to come down,
It'll be on meetup.com
I can't remember where it is. I just replied to the email, but I can dig it out. Let me know. Shall I stop now? No.
When everything works correctly, that's the first thing. Can you see this eventually leading to Skynet? I was worried it was going to, but I'm greatly relieved.
That was the stated ambition on the webpage, didn't you see? That was my tweet when the robots arrived. It was like, my robot army has arrived. Be prepared. And it was like, well, hang on, we won't be there for a week or two. We'll need a power supply. You'll have to wait while it starts up, and don't attack until I've managed to get the telly up running. We're a long way with that.
Sorry, you can kill a turtle.
Sorry?
You can hold them off and kill a turtle.
I'll just get it up on screen, but look, this would be stopping you. This would be stopping. We'll get it to make the sound.